everyone, so it's good to see you all here again. I'm Natasha and welcome back. So today we're going to continue chapter 2, relations and functions. So in the previous video, we're discussing about the functions and their graphs. So in this video, we're going to discuss about the last function, which is greatest integer function, GIF, which we can also say as GIF, GIF, greatest integer function. And greatest integer function is also known as floor function, or we can say step function. So we can call it from any of these three names, so whatever. So let's get started. Okay, so as I've told you that we're going to discuss about greatest integer functions. So okay, let me write the heading for that, the topic. It's the actually seventh one. Seventh one, it is greatest integer function. Okay? Yeah. So what is greatest integer function? It's talking about something maybe it's going to be related to the greatest integer. That's what it's just trying to say. And yeah, one more thing that, we'll take the help of the graph. So of course a graph will be drawn here. So I'm just drawing it. Making the graph, the x-axis we have, the y-axis, the negative y, and the positive I already written. So it's going to be negative x. Oops. I don't know what did I just made. Never mind. Okay, so it's negative x. Got it? So we have the positive y, the positive x, negative y, and the negative x. Okay, that's just of course common. So we're not going to discuss about it. And this is our origin. 0, 0. And let's write the numbers also. So just let me write the numbers. I'll say 1, 2, 3, 4. 5 and 6. And right here I'm going to say negative 1, negative 2, negative 3, negative 4, negative 5, and the last one, which I'm just going to write here is going to be negative 6. Okay? Yeah. And here I'm going to say negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. And oops, it's actually not the negative one. I just really forgot about it. It's actually the positive y-axis, so it's incorrect. Let me write it. Let me just make it again. Okay, straight line. And it's going to be y-axis, positive y. So here we have the positive 1, 2, 3, 4, 5, and 6. Okay, now that's correct. And here I'll have the negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. So finally, I've done this graph, and let's move on. Let's just get back to our topic. Later on, we'll be discussing about the graph. So for now, let's just leave this topic. Okay, so greatest integer function. So it's kind of a function it's talking about a greatest integer. So, of course, this function will include the integers. It can be the negative integers and the, the non-negative integers, which I can say the positive integers, isn't it? So, greatest integer function is a type of function. So, it is a function which gives the which gives the largest integer which is less than or equal to the number. I can say the integer. So like it gives, what does this function give? So it's like it is a function which gives the largest integer which is less than or equal to the number, okay? For example, let's say I have like 3. So actually this through this way I'm going to write the greatest integer function. So this is like the symbol, and we can also draw it like this way, these square brackets which we usually use, and the second way to draw this way, okay? Okay, so let's continue. So if I'm going to say that what is going to be the greatest integer of this number, so it's actually going to be 3, as we can see simply. Okay, let's take a twist, a little twist, okay? Okay, let's say 2, -2. Or maybe I'm going to take something like in points, okay? Something like in points. Let's say 1.7. 1.7. So 1.7 is just like related. So I can say like for the 1.7, 2, you'll be saying like 2 is the greatest integer function. Maybe you'll say that. So so in this case, if you like, so just in case not to get confused about greatest integer function, I'm going to take more easiest example. 1.2. That's it. So of course in 1.2, what we'll say is that 1 is the integer which is less than or equal to, which is less than or equal to the number, okay? That's what I can say. So, and in this case, like it's equal to the number, so this is also correct and this is also correct. So everything's like correct. So greatest integer function, what will it do? So greatest integer function will round any number to the nearest integer, okay? So what will the greatest integer function do? It will round any number down to the nearest number, okay? So this function will round any number. This function will round any number down to the nearest integer. Down to the nearest integer. That's what we have. Nearest integer. Okay, so this function will round any number down to the nearest integer. So that's what we can say. And or in the simple way, or in the other way that I can say, this is a function which gives the it gives the largest integer which is less than or equal to the number. That's what I can say. And we can also write it this way. So what is exactly doing? So it's rounding the number down to the nearest integer. Like we can see 1.2 is equal to 1. So like which is less than or equal to the number, as we can see clearly, isn't it? Okay. So let's get to our graph 1, okay? So it's like kind of like making this kind of pattern. Like if I'm gonna say there's a point right here, okay, right here, then it's gonna make like this way. Then just it's here, it's gonna make another point. Just it's here, it's gonna make another point. So through this way, like it's gonna make a staircase. I can say, just if I'm gonna join them, they'll be like, making this kind of pattern, okay? This kind of pattern. Okay, so here and then here, okay? I'm just making it. So, and it will, and to the same, it will go, it will continue like in this way. Wherever it is, it's going to always make this kind of pattern. Okay? So it's just like this way. So what if I'm going to say like, wait a second. Okay, just like this way. So it's kind of making a stair-like position, as a floor. So why is it called a step function? Why is it called a floor function? Because we can see something like which is actually related to that name, isn't it? So, for example, let's take this in a really easy way. Okay, so I'm just going to talk about, okay, let's say that I have just a point right here, which I will say 1.2. Okay, let's say this. 1.2, the point which I'm just having right here is like, and what I wrote was that this like its greatest integer function, and this number we're having is equal to 1. Okay, so it's like kind of like this way. So these all points are like making any relations, like this is for the 3, this is for the 2. So what is it like making that for the 2? For the 2, it's like, making kind of like greatest to, I'm going to say from smallest to, the largest, the greatest, I can say. So that's what it's making, isn't it? So, to understand it in the graph way, it's really simple, nothing's hard. Okay? And to just understand it like mathematically, just like we do in this way, it's more easier. Okay, so let me, if I'm going to discuss about the domain and range of the greatest integer function, in which like I have all these cases. So one thing that I'm going to write, which is fx. So fx will always be there. So for this graph, what I'm going to say is that f of x is equal to the greatest integer x. Okay? So fx is equal to x. But yeah, one more thing that we're going to notice, that we're talking about the greatest integer function, so it's kind of like different from the others. Okay? So that's what we can see. So fx is equal to, for the greatest integer of x, I can say, okay, as we're looking for the x. Okay, so about the domain and range, let's say this about the domain and range. So, about its domain will be negative infinity to positive infinity. And one thing that we're always going to use this in the interval form, I'm going to say this is an open interval, because like infinity is infinity, like it can't be closed, isn't it? So it's like kind of really simple. So we're never going to use a closed interval, which is like this way. No, it's always going to be like this way, opened. So for the infinity side, I'm going to use this. And about the range, I'm not exactly sure about the range. As one thing is common, one thing's for sure is that range is dependent on the greatest integer function, whatever like we're having. So it depends on the integer, on the number we're having, okay? But if I'm going to say that whatever the range is going to be, it's going to be the integer. So it's just in a simple way, I'm going to say that this range is equal to integers. So whatever range I'll get, yeah, one thing for sure is that the range, it will depend on the number we're having, okay? Like what kind of number we're having. Is it this one or this one? So like it can be anything. So first thing, it will depend on the number. Second thing is that whatever the rate, whatever the number will be, the range for sure is gonna be an integer, nothing else. So what I'll say that in just a simple way that range is equal to z, and z is for the set of integers. So it's like kind of for the, expressing the integers. So it's, for the integers. So range is equal to the integers. That's what I'm going to say. So just a simple way if I'm going to say that. Okay. So one thing that to understand this more clearly, I'm going to say this, that this x is equal to, let's say, what number should I take? Okay, then let's take -1. Okay, so the -1 is for what? -1. What is this? Less than or equal to. So it is -1 less than or equal to x, and x is less than 0. Okay, and if I'm going to talk about, if I'm going to say about the, let's say 0, then it's going to be 0 for 0 less than or equal to x, and x is less than, what it will less than 1. Of course, it's really common. So this is it's gonna follow this kind of pattern. I don't know why why do I always need to rub it? X is equal to, let's say, 1. So 1 for 1 less than or equal to x, and x is less than 2. So it's kind of going to follow this kind of pattern. So for the 2 also, 2 for 2 less than or equal to x, and x less than 3, and so on. Okay, so it's going to be it's just going to read it like this way. So this is how we're making a relation. So this is how all these points are coming, all these things are coming. So it's saying that -1 for -1, which is going to be less than or equal to x, and x is gonna it's going to be less than 0. So that's what it's making. Then this kind of pattern it's making. So for sure it's going to be this way. So so that's all for today in the greatest integer function that we've discussed. So, but yeah, one more thing that we're gonna discuss about all the functions. Not all the functions, but some few functions like polynomial functions, greatest integer function, rational function. About all these functions. So we're going to discuss about these all functions in in more detail, in some another video, okay, some other video. So we're for sure I'm gonna discuss this topic with you guys. So just to in that video, I'll be discussing some questions and getting to know more about these functions, all these things that we're going to do. Okay, so in the next video, we'll be solving some questions maybe, and or maybe I'll be just continuing the topic. So I'm not exactly sure that what I'm going to do. So whatever we'll do, it's gonna be fun. Okay, so thanks for watching and have a great day.